Hello, I am Anish Padma, Assistant Professor, Department of Computer Science, Sri Vijay Vishalakshi College for Women. We are going to see a topic, input buffering in compiler design. This is the agenda of this presentation. So these are all the prerequisites we need to know before starting our topic. So to understand input buffering in compiler design, a few terms need to be understood. So we'll discuss those terms first. So lexical analyzer finds a lexeme part of an identifier, must add it to the symbol table, and not only recognize lexemes but also does pre-processing on the source text such as deleting commands and white spaces. A lexeme is a sequence of characters in the source program that fits the pattern of our token and is recognized as an instance of that token by our lexical analyzer. A token is a pair that consists of name and value in each attribute, and the name is a symbol that denotes the type of our lexical unit. And a pattern is a description of various forms of tokens lexemes can take. And for a keyword as a token, it's just a series of characters up to this term. Introduction. Buffers is temporary storage we use when one component feeds data into the other, but their speeds aren't same at the same time. So the basic idea behind input buffering is to read the block of input from the source code into a buffer and then process the buffer before reading the next block. Actually, it is a region of a memory used to temporarily hold our data that's being moved from one place to another. So it is used when moving data between processes within the computer, and the majority of buffers were implemented in software itself. So it's an important concept in compiler design that refers to the way in which the compiler reads input from the source code. It must be read one character at a time, which can be slow and inefficient process. So this technique allows the compiler to read a large chunk of our data, so that can improve the performance and reduce our overhead. So in lexical analysis, scans the input from left to right one character at a time, so it moves two pointers, one as a begin pointer and the next one as a forward pointer. And these are the major things in input buffering. Buffer pairs, that's a technique used to reduce the amount of overhead which is required to process an input character in moving characters. And sentinels are used to make a check each time when the forward pointer is moved. A check is done to ensure that one half of the buffer has not moved off. If it is done, then the other half must be reloaded, like that. The pointers is to type. It is used to read a character from left to right to identify a token. So the pointers are begin pointer and look ahead pointer. Scheme is used in different types of buffering methods. One is input buffer, the other one is to buffer scheme. A pattern is a description in the form of lexeme for a token may take. In any keyword as a token is just a sequence of characters that form our keyword. And this is the picture of a buffer pairs. It's a large amount of time consumption in moving characters. So special techniques have been developed to reduce the amount of overhead required to process input characters. And the schemes consist two buffers. So each consists n character size, which are reloaded alternatively. And pointers use lexeme begin as the beginning of our current lexeme, which is yet to be found. And the forward pointer scans ahead until a match for a pattern is found. And sentinels, when the forward pointer is moved, a check is done to ensure one half of the buffer has not moved off. If it is done, then the other half must be reloaded, which is have two tests. One is check for end of the buffer and to determine whether the character is read or not. That could be shown in this picture. And these all are the begin and look ahead pointer. So begin pointer is the beginning of our string, which is stored in the buffer, and the look ahead pointer is moves ahead to search for the end of our token, which is shown in this image. And generally a buffer can be divided into two hops. So if the look ahead pointer moves towards hop in the first hop, the second hop is filled with new characters to be read. So the look ahead pointer moves towards the right end of the buffer. The second hop, the first hop will be filled with new characters, and it's good. And it has been shown in this picture, the begin pointer and the look ahead pointer. This is the first hop and this is the second hop. This is our input buffering concept. Let's see the pros and cons of input buffering. So it can simply design the compiler by reducing the amount of code required to manage input. So it usually just does not test to determine the forward pointers pointing end of the file. The average number of tests per unit is extremely close to 1, since n input characters encountered in the end of the file. So if the size of the buffer is too large, it may consume too much of memory, leading a lower performance, and sometimes it can cause crashes. So if the buffer is not properly managed, it can lead errors in the output of our compilation process. The majority of the time, this approach works effectively. However, the amount of look ahead is restricted. So overall, the advantage of this input buffering is generally overweight the disadvantage when used appropriately, as it can improve our performance and simply for our compiler design. So let us conclude our topic. The input buffering is a powerful technique used to compiler design to optimize the performance of our compilation process by reading input as a chunks. Input buffering techniques used file mapping or memory mapped input output mapping, commonly used in real world compilers. So input buffering in compiler design is the choice depending on the specific requirements of our compiler. So in overall, input buffering plays a crucial role in improving the speed and memory usage of the compilation process in the large input files. So it is important for compiler design to consider implementing input buffering part of their design strategies to ensure optimal performance of the compilers. That's all. Thank you for listening.